Hi everybody, in this video I'm going to show you, I'm going to talk about spectra, which is the new thing we're studying with light, and then I'm going to show you how to sketch some spectra. So here we go. Spectra is the name of this slide, and it says plural for spectrum. So we'll be talking about what is a spectrum, but when we're talking about multiple spectrums, really we use the word spectra. And it's a very important thing in astronomy, so here we go. So here are the essential questions for today. What is a spectrum? And I wrote the plural as spectra. What information is contained in a spectrum? Like what makes these so important in astronomy? And how do we sketch one? This is what we'll actually be doing today for the assignment, is sketching these. So here we go. Let's keep going. So I've shown you a couple pictures of these in previous videos. This is a hydrogen tube. This is just a tube filled with hydrogen gas, and then it's electrified and it emits this light and it looks purple to our eyes. People make signs out of these and put them in windows like at Silas and Maddie's, right? You can bend this glass into signs and make lighted signs. That's what hydrogen looks like. It looks purple. Here's helium. This one's really bright. It's actually kind of yellowish. So helium has a very yellow color to our eyes. Here's a nitrogen lamp. People make signs out of these too. It kind of looks like helium, a really bright, rich, sort of yellowish, bluish color. And then this one was so bright I had to turn all the lights on. That's neon. So that's just neon gas in a tube. And neon lights are really famous, right? Like that's when you see lighted signs, we usually think of neon lights, but really they can be neon or nitrogen or helium. They can be any gas because each gas gives off a different color when it's electrified. And that's kind of what starts this discussion, is what happens when we analyze these lights. So that brings us to what is a spectrum. A spectrum is really when we break up this light and analyze it. So astronomers use prisms and more often diffraction gratings, which is kind of like a prism, to break the light up and spread it out. So instead of seeing the purple hydrogen lamp, we break it up into its individual components, kind of like a rainbow, and see what it looks like. When you break the sunlight up, it turns into a rainbow. When you break other lights up, like a neon light, it doesn't necessarily turn into a rainbow. But what a spectrum is using that diffraction grating or prism to break the light up. And it lets us see how much light an object emits at each wavelength. And we learned yesterday that the wavelength will tell you about the color. So that's what we're going to do today. Our eyes just combine all the colors, but a spectrum breaks them up so we can study them specifically. So whereas the hydrogen lamp looks purple and the neon lamp looks orange to our eyes, when we break them up, we see what individual colors those are made of. And that tells us information, especially if we're looking at a star or a galaxy. But kind of getting ahead of ourselves. Let's just stick to the spectrum for now. So when you look at hydrogen with a spectrograph and break up its spectrum, it looks like this. There's a bright red line and a pretty bright green or blue line, and then there's actually a couple purple lines right there. The reason these pictures are so bad is because I shouldn't say bad, the reason they're so grainy is I took them with a spectrograph here in class with my Samsung camera. So these are actual pictures I took. Helium looks like this. It's not a rainbow at all, it's a bunch of individual colors, right? Nitrogen looks like this, that nitrogen lamp. Kind of a rainbow, but a bunch of little smeared lines in there, and gaps too. And then neon looks like this, a bunch of individual bright lines. And together they combine to make that look really orange when our eyes see them without a spectrograph. So the spectrum tells us how much light there is at each wavelength. And we see that it's not a rainbow, it's individual lines. And that tells us something about these gases. Helium hardly has any. Hydrogen just has like 4 that we can see. So we're going to learn how to sketch a version of, this is actually a spectrum, we're going to learn how to sketch a version of these today. So what are we going to do? We're going to practice sketching something called an intensity spectrum. You will need paper and something to help you make a straight line, a ruler maybe, something to write with, and colored pencils or crayons if you have them. So right now you can pause the video and go get all this stuff. I'm going to keep going, but pause the video if you need to go get some of this stuff. And we're going to sketch, I hope. The next thing you're going to need to do with your pencils is make yourself 2 copies of this right here. This is a blank spectrum, and this is what we're going to sketch on today. You need to take the time to make yourself 2 versions of this right here. Doesn't have to be perfect, but you got to get the wavelengths on the x-axis and label 4,000, 5,000, 6,000, 7,000, and 8,000. This will get us from blue and purple all the way up through red. And then over here is just the intensity. Real bright is up here. Real dim is down here. It gets brighter the taller it gets. So we're going to sketch on these. Would you pause the video and make yourself 2 of these right now? And I'm going to keep going. So hopefully now you have your pencil, your paper, you've sketched 2 of these, and we're ready to go. Here's the other piece of information you're going to need. The wavelengths and color ranges of each color. So this tells you that violet is anything from 3,500 angstroms all the way up to 4,200. Blue is, this should really be 4,200. Blue is 4,200 up to 4,800. Green is 4,800 to 5,500. Yellow is 5,500 to 6,000. Orange is 6,000 to 6,200. And red is 6,200 all the way up to 7,500. You're going to need these numbers. I suggest screenshotting this so you have it. Just hit Command-Shift-4 and take a screenshot like this. Command-Shift-4. I would recommend doing that just so you have access to this rather than copying it down. But one way or another, take a minute to screenshot this so you have it, or copy the numbers down if you prefer that. Pause the video and do that. And now we're ready. So I'm going to shrink my screen a little bit. This video has already gone 7 minutes, so we're okay. So now we're going to practice. You know what? I guess I need to go back to present. So here's what we're going to do. We're going to sketch 2 intensity spectra today. We're going to sketch hydrogen and helium. I will tell you what color the lines are and how bright they are. And you're going to draw them on your spectrum, those 2 spectra you just drew. I will do it too so you can see an example. Yours might be slightly different than mine, which is totally okay. And the color will tell us where to draw the line. So I'll tell you what color it is, and then based on the angstroms, we'll know where to draw the line. And the brightness will tell us how tall to draw the line. This is what we're about to try to do. So let's start with hydrogen. Hydrogen has a bright red line and a medium blue line and 2 very dim purple lines. So get this written down somehow, because I'm about to go away from here. We're going to do a bright red line, a medium blue line, and 2 very dim purple lines. And I'm going to show you how to do that on your spectrum. All right, here we go. So I'm going to need this right here, these colors, and I'm going to need my blank spectrum. So we have a bright red line first. So a red line's got to be between 6,200 and 7,500. So that's got to be up here, right? Between 6,200 and 7,500. We're going to draw a bright red line. Now you don't have to use red to do this. I'm going to. So I'm just going to put mine at 7,000. That's an okay place to put it. That's in the red range, right? Anywhere in this range. So I'm going to draw a really bright line. And a bright line means, uh-oh, got to click that. OMG, come on. Don't do this to me. Okay, so I'm going to draw a bright peak like this. That is a bright red line. And by bright, I mean it was a curve that went way up to the bright part. Now, there we go. That's what a bright red line looks like. You don't have to color it in. This just shows us there's a line at 7,000, which is red, and it's a very tall line that goes up to the bright. There's also a medium blue line. So for blue, it's anywhere between 4,250 and 4,800, so it's right around here. So I'm going to change this to blue. If you don't have colors, it's okay. You can draw it whatever you want, color you want, because really the wavelength tells us the color. I'm going to draw it right at 4,800. I was hoping that'd be, I kind of wanted that to be blue. Let's try that again. Let's do, there we go. I'm sketching. right about here, I want a medium blue line. There we go. Looks nice. And then there were two, what just happened? There we go. There were two very faint purple lines. So I'll change this to purple for mine. And for very faint, they're going to be like, purple's way down here by between 3,500 and 4,200. So just right around here. No, don't do that. I didn't really want that either. Let's try that again. Two faint purple lines. And you know what? That's a pretty good hydrogen spectrum right there. Two faint purple lines, a medium blue line, and a bright red line. So the wavelength, or the color, told us what wavelength to draw it at. And then how bright it was told us how tall to make the peak. Now I want to get rid of all that stuff I did. Can I do that? Oops. Where's my blank spectrum? I hope it's still blank. Oh, good. So there was one example. Hopefully yours looked similar to that. Let's look at the next slide. Here's an example of a hydrogen spectrum that I took with a machine. So there's a bright red line. I didn't get mine at just the right spot. I put mine at 7,000. For today, that's fine. There's your bright red line. There's your medium blue line. And you can barely see the purple ones, just little tiny blips. So yours does not have to look like this, and it doesn't have to look like mine. But hopefully you got a bright peak over here somewhere, a medium peak over here somewhere, and then a couple small peaks over here. And that's a hydrogen spectrum. And I'll tell you what, based on how long this has taken, I'm going to end this video right now. So all we got done was the hydrogen spectrum. Let me go back to view. I know I went quickly through that, and tomorrow we're going to continue and try helium, but we're not going to do that today. If you thought I went through that too quickly, you can re-watch parts of this video. That's probably a good idea. But definitely ask me if you need help, and tomorrow we will continue, and we're going to move on to a second spectrum called helium. Okay, thank you.